Hey everyone, this is Ray from Zapsec. In this demo, I'll be diving through how we're using Microsoft Azure AD B2C to enable secure user migration and passwordless authentication with keyless, which is a zero-knowledge biometric solution that's built for customer identity management. To start this off, I will go ahead and share a screen of what we're going to go over here. So, starting with a quick overview of the CIAM runway. So what you're seeing here is Microsoft's modern CIAM platform, Azure AD B2C, which is positioned as a platform as a service-based solution for scalable customer identity here. You can see here our legend. So green, the green boxes represent what will what's demoable right now. What we'll go over today is the user migration just in time and the passwordless with Face ID biometrics with keyless. The blue kind of shows what would come in the phase one of the project as we work on an item, on a production use case. And gray are the client assisted areas where we would typically guide governance and security, things like helping secure policies across the environment with Azure Policy, um, working with the client. Um, so migration is always the most sensitive part of identity modernization. And this page shows how Azure AD B2C supports both bulk and just-in-time migration strategies. You can see here that we have around three pre-migration strategies that we can choose. And we have two just-in-time migration strategies, essentially. The one we most commonly see in enterprise scenarios is where we're migrating. Passwords are usually hashed, and so we would migrate with a random password. We would pre-migrate with a random password, and we would employ an API to set their password just in time and allow for pure just-in-time sign-in for users that may have been missed in the bulk migration. So we can see here that we have two paths here. I've highlighted the bulk migration to be in purple, which also records what I say here, and the JIT to be in blue, which is what I say here, kind of a small description of it. So on the left, we can see that we have two bulk migration strategies. You can bulk migrate using Graph API in all three scenarios. And this one is for if you have clear text passwords. If you have the actual password, clear text passwords, it is the most straightforward. It's very unlikely for enterprises to have them in clear text, but if that is available, that would cost the least amount of downtime as you really don't need any APIs for just in time. You can have it for you pure just in time for backups, but you can expect the load to be very low for it because you've bulk migrated all your users beforehand with their passwords. The second migration strategy would be bulk migrating without passwords, where you would perform dynamic group assignment with the bulk migration based on the business logic. The user would attempt to sign in, and then we would do the just-in-time password validation. We would validate their credentials against the legacy identity provider, set password, re-authenticate the user, and we have our JIT migration right here for our backup scenarios where they may have been missed in one of these bulk migration scenarios. Maybe maybe the console kind of errored out, and then we had to do some retry logic, or a user was just missed in the initial JSON file. We have a JIT migration backup flow for that, where a REST API would verify the credentials against legacy IDP, just like how it's happening here, except this time the user is not created in the directory. And so we're going to create them in the directory, set the password on that user, and we also place a message on an Azure queue to introduce some delay so that the user can be detected in the B2C directory, and then we can go ahead and assign them a group. So we have an event-driven approach here. You can see here that for bulk, we would be using a .NET console application. We would dump our user records in a migration JSON file. We would either migrate with the password values as empty, or with the passwords in there, and we would That would pre-create the user account with the legacy attributes. On first sign-in, we would validate password against legacy if we migrated with a random password. If the password is valid, we update the password, new password on their B2C profile. We set up the MFA, which we will see today. We are demonstrating keyless as passwordless MFA, and we would apply conditional access from the very first login. Just in time is also what I explained. Pretty much their credentials are checked against legacy. Their account is created in Azure. They can also, if they forget their password on first sign in, that's also handled with the just-in-time forgot password, where they will get created in the user directory, and the password they choose in the reset will be their new password. MFA will also happen in this case, and conditional access is also enforced from the very first login. Some important things around the business impact here are segmented migration. We can phase and bulk migration in waves of different user groups. And that allows for more control over the groups. We have time to productivity, which means the median time, the time to from first sign in to full access with the groups happening, the dynamic group assignment happening for pure just in time, seamless access for the user and access control set from the very first sign in is elevated. And we have migration coverage and quality. We have logging and analytics placed for migrated users. We can track percent of users, that were migrated via a migration attribute. We can track which users successfully, captured biometrics for MFA, which ones didn't. The group assignment success rate via the API, um, and necessary things like so. Transitioning to passwordless, once the migration is in the migration process and we want to introduce MFA, right, in the migration process, we have a couple of options here. You can go with SMS, TOTP, but we can also introduce a passwordless option for MFA from the very beginning, where the during migration, we would still use the password because we need to verify the user's credentials. So we need the password for the initial migration. And during that migration, we can also set up a FIDO2 or Face ID cryptographically based approach, which are phishing resistant approaches here. Okay, and once migration is stable on the new platform after 6 months, a year, however big the user base is, the next natural step would be to improve the user experience by removing the passwords that you needed to migrate your users and shift to a passwordless solution. That would be an option that comes after the full migration is happening. But in terms of what we're going over today, the scope of what we're doing today, we're showing user migration with passwords and a passwordless solution as MFA. So instead of having an authenticator app, which can cause user friction, it can elevate support ticket costs, we can go with something a lot easier with just a Face ID biometric where the user does not need to remember something or have something that can be phished. Something important to note is that Azure AD B2C does not have native biometric or passkey support like Entra ID does, so it relies on partner integrations. You can see that there's two options here. We can go with passkey providers, FIDO2, or ephemeral biometrics, which is important. It's more Face ID, but it's device agnostic, which means that it's not device binding like FIDO2, right? If you go with FIDO2, then, if you create a passkey on your laptop, then it's going to be restricted to that laptop, right? If you're using a new laptop or a new phone, it would make you register again. Whereas in the ephemeral biometrics way, it's extremely flexible and it knows your user authentication based on a private key that's stored on the server side. So it's very device agnostic. We have Keyless on the left here as a provider here, which is a documented partner by Microsoft for zero knowledge biometrics. It uses secure multi-party computation, which means there's multiple cloud nodes that come together at the authentication event to verify the user. Um, and zero knowledge proofs to make sure that each one of those cloud nodes followed the protocol successfully. It integrates through OpenID Connect, right? So it integrates via OIDC, so it's very easy to plug in with a B2C tenant across. It works across browsers, mobile apps, etc. On the right here, we have more FIDO2 players like AuthSignal, TrueSona, and Transmit Security, which use FIDO2 WebAuthn standards. Very secure, but they rely on device-bound credentials, so they're more excellent for workforce scenarios. And while keyless, which is also can be used for workforce scenarios, is very good, but it really um, shines in consumer identity where the user experience and privacy compliance are really critical. Um, you can see here that, some of the business impact items we have are that TOTP and SMS MFA, they are phishable and they increase user churn and support costs. Biometric passwordless kind of helps get rid of the help desk volume there. We have frictionless user experience, so the user trusts the brand more, and we have reduced operational expenditure via lower support overhead for support costs, right? And this is very ideal for CIM scenarios with privacy compliance such as GDPR, PSD2, which are European regulations, HIPAA in California for healthcare, PCI DSS, a payment card industry standard, and NERC-CIP for energy, North American energy regulations. Okay, so that's a little bit about what we're about to show real quick and why we would want to go with these types of integrations. So, let me go ahead and dive into the demo right here. So if I open my Azure AD B2C directory, um, I will go ahead and go to my users and I will make sure that the user I am simulating a just-in-time um, process for is not in the directory. So this user is going to be migrated just in time, Billy. Okay. So what I've done is I have created a Spring Boot application that allows me to host a login on my local host 8080. So this would be acting like the sign-in screen the user would see. They're accessing a banking application, a healthcare application. It would say welcome. And when we click on sign in, right, this would be the actual sign-in screen for the user. You can see here that the user would enter their credentials here. I'm going to click on sign in. So this would simulate their sign in the back end. We will see this in the logs, but there is an API being verified. These credentials are being verified against the legacy store. The user account is getting created just in time. There's an event being placed on a queue for dynamic group placement. But you can see here, this is where MFA is getting triggered. So if I click on continue right here, it will ask me to allow access for my camera. So I'll go ahead and let it authenticate me right here. Um, it authenticates me. Great. It says authentication successful. And then it's going to go ahead and redirect me back to my end app, right? So we can see that, this is hosted by Spring Boot. Azure AD B2C is the IDP, while Keyless is a federated social identity provider. Um, we can see that if we click on our tokens, these are again short-lived tokens, but a new token will get generated on each sign-in, and we can see we have our access tokens right here. We can see that yeah, so we get redirected successfully. Now, to show a little bit of clarity here, if we look at our logs right here, we can see certain things happening right here, right? So what we see here is we can see certain things here. So we can see that our project called Azure AD B2C.JIT user migration starts, and uh, it goes ahead and invokes our controller. So we can see Microsoft.MVC controller action invoker. So it hit our API, local account signing. Our Azure AD B2C custom policy is hosting our API in a RESTful technical profile. So that was triggered. And the controller is called user migration. So the controller user migration is hosting this API. And you can see, yeah, AEDB2C.JIT user migration dot controller. So this is the project name dot controllers dot user migration controller. This is our controller. Um, you can see that the queue service was instantiated as we will be using a queue, and we call create account, right? So we verified the user credentials and we're not calling create account with the following parameters. So we have the user type we're using is email address, sign-in name, Billy, issuer assigned ID, and email. These are for social accounts. We're not going to use them. You can see the password that we authenticated with. Ideally, we would not want to keep this in logs. For this demo, I kept it in here. Display name, first name, last name, healthcare status. All of these are coming from the legacy system. So this is what we can get from our legacy system and create in Azure AD B2C. You can see that we have a custom attribute healthcare status provider, which we're actually using to post on the Azure queue for dynamic group assignment, right? So it goes ahead and you know, routes it to this controller successfully. Um, you can see after it creates the user, so it successfully creates the user, what it does is it sends some user info to an Azure queue. The queue payload it sends is the sign-in name as well as the healthcare status. And this is what will actually assign the user to the right group. So if we go back to the user's profile now, you'll see that he's created just in time. He got created just in time. And if we go ahead and go to groups, since his healthcare status was provider, he's been added to the provider portal users group. And so this allows for dynamic group assignment and a way for seamless access control via the very first sign-in, which really helps with privacy compliance and automated access management. So very, very important to know that there. Right, so the message gets successfully sent to the queue, right? And we go ahead and return OK to B2C with the payload. Um, and yeah, it basically, successfully, we can see a 200 at the bottom here. So the API is successful. Um, and everything we wanted to happen basically happened, right? So we're able to track that via these Azure App Service logs. We can also track things via an application insights logs, which can really help us determine different events. So we can see here, Azure App Service kind of gives us more deep insights into our code logging, while for specific telemetry to retain, we can use our application insights instance and feed this into our log analytics workspace so that this can be fed into a SIM tool for logging, monitoring, reporting. But we can see here that this event just got generated for me, and you can see that the event instance, first thing that's happening is authentication. Okay, the second instance, the event instance that's important here is it's B2C. Some things are happening in the back end right now. Client CSP report. This is making sure that the page is secure, and the page that we're landing on, the Spring Boot page that's hosting the login, and then the login page that's hosting it is secure. Right. So it's just making sure it's doing that. And then you can see here that event API is being hit. So our API is being hit and the user is getting created just in time. And we're able to see some claims exchanges are happening here between, the legacy system and B2C. A token is being generated by Azure AD B2C. And then finally, we have some metadata being generated at the end. So basically, for deeper insights on what exactly is happening process by process, we have captured things in the application logs in the Azure App Service. And for deeper retainability, we can create custom Kusto queries where we can see the events in here and we can go ahead and log these changes to make sure we have full auditing and observability. So to kind of wrap this demo up, we demonstrated how Azure AD B2C can manage both, legacy user migration and passwordless MFA through a single platform, single user journey. And, the .NET APIs and the Spring Boot APIs are kind of helping handle the API orchestration, hosting the custom login page. And then Keyless is kind of delivering the zero knowledge biometric authentication, while Azure App Service logs, and then application insights logs are giving full visibility into the journey. So together, this forms a reusable accelerator, for CIM implementations with Microsoft. One that's really secure, scalable, and built for real world modernization. And, with this now in place, we would be able to expand into additional adaptive risk policies, maybe different regional tenancy based on global identity requirements, et cetera, right? So thank you so much for watching. This was a demo of the passwordless CIM accelerator on Microsoft's CIM Azure. Thank you so much, and have a good one.